Welcome to What the Fuck Do You Do? A show where we learn about various professions and what people actually do in their jobs. I'm your co-host, Shrey Panda.
And I'm your co-host, Travis Fox.
And today, the job we'll be talking about is an astrophysicist. Our guest today is Sarafina Nance, who is currently an astrophysics PhD candidate at UC Berkeley. She's also the host of the astronomy show Constellations by Seeker, a series dedicated to exploring the most mind-blowing aspects of the universe and uncovering our cultural ties to the cosmos. She is the author of the forthcoming children's book, Little Leonardo's Fascinating World of Astronomy, coming August 2021, and just signed another publishing deal for Starstruck, a memoir and exploration of the wonders of the universe. Lastly, she has been selected as one of Forbes 30 Inspirational Women and one of Arab America's 40 Under 40. Needless to say, she is a very distinguished guest, and we're very excited to have her. Sarafina, thanks for joining.
Thank you so much for having me. I'm excited to be here.
Awesome. Yeah. So to start off, how would you explain what an astrophysicist does?
I would probably say that we use science to try to understand the universe.
I like.
Should I go into more detail?
I like that. What does that actually mean on like a Monday morning when you wake up and you're like, I'm an astrophysicist and I have to be one today?
Yeah. It's funny because I don't think I even knew what an astrophysicist did until I came to grad school. And I was like, wait, what? I thought I was just going to look through telescopes and learn about the sky. But it turns out my job basically consists of coding and sifting through data and trying to make pretty plots from that data and analyzing the plots and writing up papers about it.
When you say coding, what exactly are you coding? What are you building?
So the current code, let's see, what am I working on right now? I am trying to basically, when I point a telescope at a target, let's say a galaxy, and I look for the spot where the star was before it exploded. And I should rewind a little bit. I'm an astrophysicist who studies supernova, which are exploding stars. So that's what I'm looking at when I, point my telescope at the sky. And the telescope is basically this huge light collector. And so the light leaves the object, travels through space, and ends up at my telescope. And I basically take the photo that the telescope took of the object and break it down into pixels or whatever unit you want to use. And then I analyze the light in each pixel. So I can basically plot the light over time to try to understand sort of the trajectory of the object in terms of light before it exploded. I can break up the light into its constituent wavelengths and try to analyze those wavelengths to tell me something about the star. So we basically use a variety of tools and machines to get our data. And then when I code, I write programs to help me analyze that data better.
Got it. Okay. So let me take a step back. Why exploding star? Like what is the purpose of understanding how an exploding star occurs and tracking all that data?
Yeah. Other than the fact that there are explosions in space, which is just awesome. I like exploding stars because supernova are the birthplace of heavy elements in our universe. The old adage, Carl Sagan said, we are star stuff. And we are. I mean, every element aside from hydrogen and some helium in our bodies was formed in the innards of these stars. They also basically trigger star formation. So they, when stars explode, they eject really high velocity winds, and those winds can tear through surrounding space and trigger star formation nearby. So supernova are cool because, they shape the cosmos around them in more ways than one. And so that's one answer. the other answer is sort of on a more technical level. I get to use supernova to help me understand the evolution of the universe. And so when I say that, I mean that these supernova are basically distance indicators. And by analyzing, how far away they are and how bright they are, I can learn something about the rate of the expansion of the universe. And so these supernova help me understand the composition of the universe and the evolution of the universe, which is sort of intrinsic to the rate of the expansion of the universe.
That's absolutely fascinating. Like figuring out how fast the universe is expanding and directionally. Like what are some of the things that you've been able to discover through your research?
I wish I'd been able to discover more. I think, the first thing I discovered was how to write code in Python. Like I did not know how to do that until I got to grad school. And from writing sort of these codes and analyzing my data, I found a supernova. So that was really cool. It was a star that nobody had ever observed before explode. So, that was probably my shining, no pun intended, shining moment in grad school.
And how big is this field? Like how many people around the world are studying supernovas and actually making these sorts of discoveries?
That's a good question. I should know this answer. I think it's I would say probably somewhere in the ballpark of a couple hundred, 100.
Oh, wow.
It's big, but not big. I don't know. How many astronomers are there? It's actually quite large part of the astronomy community, but in total, it's really not that many people.
So I guess that brings up a question that I have is, the path to get to this point as an astrophysicist, right? Like I think there's tons of people who, have fancy telescopes in their backyard and they take it out into a rural setting and check out the stars. But, what is the path that you take from that general interest to actually being qualified the way that you are?
Great question. So I knew I wanted to do astronomy since I was in elementary school. And I knew I wanted to do it. The passion was there, but maybe the skill wasn't there. Or I didn't think it was there. I struggled a lot with physics and math as a kid until I really found mentors who helped me develop my skills. And so that mentorship to me, especially in high school, meant everything. So I had an astrophysics class in 11th grade, and I had a teacher who really communicated science in a way that was exciting, was accessible, made the students want to get involved, even if they didn't fully understand the concepts. And that was everything to me. So I was able to work with him my senior year of high school to do basically readings on supernova and dark energy, and ended up going to college to study physics and astronomy. And again, in college, I had an incredible mentor who was very patient with me and helped me sort of, learn what it meant to be a scientist. And with that mentorship, I was able to start to find my footing in the field, and I'm still finding it. But, it was a long journey. And I think the number one thing that helped me get through it was mentorship.
And what are the credentials that you need to get to where you are right now? Do you need to major in a specific field in college? And do you need to go to a specific college?
I think it's helpful to major in a STEM discipline. But it doesn't have to be physics or astronomy. There's someone in our program who was an engineering, I don't know what type of engineering, but some sort of engineering major in college. But that said, if you want to major in English and think astronomy is really cool, and maybe you want to get an advanced degree in it, I don't think that should hinder you. I think doing research in undergrad helps more than anything, more than your degree or your GPA.
And to even be in any sort of occupation in astrophysics, whether it's a technician, whether it's a PhD candidate, do you have to go to college?
No, absolutely not. There are people who work at observatories who I don't think you need to hold a college degree to do. There's so many parts of astrophysics that are not limited to the science. So like there are artists who do, beautiful works for planetariums and museums that are science related, but I could never do, right? And there's, tour guides and science communicators and teachers. So there's like a wide swath of people, I think, that all have some sort of intersection with astrophysics.
And for your particular route, like where do you take it from here? Is it publishing additional research? Is it like expanding the field of the research itself? Like what are some of your goals moving on from this point?
If I were staying in academia, those would absolutely be my goals. But I plan to leave after I get my PhD. So, I plan to publish a couple more papers and then graduate hopefully next August. Fingers crossed. And then beyond that, I plan to get into the space industry from sort of the private sector standpoint, industry standpoint, rather than academia, whether that's training to be an astronaut, whether that's, developing the next SpaceX, I don't know, but some sort of other sort of intersection like we just talked about with astrophysics.
Do you want to go to space?
Yeah. I do.
Is it scary? It feels to me like it would be scary.
So I just applied on a mission that I didn't get, but I applied in February, and as I was applying and right afterwards, I was like, oh, this is going to be great. I'm so excited. I keep thinking about seeing the Earth from space, and I got really emotional. And then SpaceX's, I forget which rocket, had an explosion on the landing deck. And I was like, I thought this through. Like, do I really want to actually put myself through this? And, there was a little bit of moment of fear, but, we're at the time now in the space industry where private spaceflight is really starting to emerge in a real way. So I think it's really it's an exciting time. And hopefully if they're sending, Joe Schmoes like me to space, then it'll be safe. But I mean, it's obviously, maybe it won't happen in the next 5 years. Maybe it'll be another 15 years. I don't know, but I'm more excited than scared.
And I mean, that brings up an interesting point. When I think about astronauts, I think about this idea of exploring the final frontier, right? It's about discovery, about seeing things from a perspective nobody's really seen it before. It sounds like you've done that in your research too, finding this unexplored territory or unexplained phenomena. Do you think that exploration or a desire to explore is kind of the common factor of people getting into this field, or what draws the I guess common person to this?
I love that point, and I think exploration is a huge part of it. You'll find if you ever talk to a room of astronomers or astrophysicists or astronauts, whatever, and you ask them, do you like or love space, and everybody will raise their hand. And then you ask them, do you like to go mountain climbing? And 90% of them will raise their hand. There's this common sense of exploration and pushing yourself and, curiosity. And I also think, when I love to do both of those things. And when I am either stargazing or I'm out in the middle of Big Bend looking at a, mountain, I feel the same sense of overwhelming awe and perspective. And I think that a lot of astronomers feel that same way about space.
And do you know, just either anecdotally or by the numbers, do you know where people typically go in academia versus industry?
Most people enter grad school wanting to go into academia. The attrition rate, not to get through grad school, but to remain in academia afterwards, I think is quite, the attrition rate is high or higher. I mean, the issue is there's a bottleneck of number of positions across the country and across the world in universities for astronomy. And so, just by virtue of the fact that there are very few positions means that most people can't get a job, even if they wanted to. That said, I also think that there's dialogue happening, especially right now, about the culture of academia and how toxic it is and how unsupportive it is. And so there are a lot of people who leave because it's not a safe environment. It's not, a good environment. Many people go to data science. Some people go to finance. Those are, I think, typically the two biggest routes that people take.
And when you mean it's not safe, what do you mean by that?
Yeah, I mean, academia as an institution is racist and is sexist, and as a culture is not supportive towards any marginalized groups. And then when you add intersections of marginalization, people get pushed to the sides or pushed out. It's hard because I think people really want to change the institution because, we love what we do, but it's very difficult when it's there. It's just very hard to change an institution like that is built upon sort of these racist, imperialist, colonialist foundations.
Combating that, and combating the historical pitfalls and I guess obstacles within higher education and academia, like what does it mean for you to be trailblazing as a woman in this incredibly technical field?
It's hard. I feel very lucky. Not just I love what I do and I love astronomy. And so I'm lucky to be able to study it because I am, but I'm lucky because many people get pushed out who should be here studying it and are unable to. And so that's, equally frustrating and scary. And my goal is to change reality of whether it's STEM or astronomy or academia and make it better and change it for future generations, especially, generations of young women and women of color. So, it's very meaningful work, I think, but it's incredibly frustrating at times.
And what advice would you give somebody who is a woman or a woman of color or person of color who wants to pursue this field in academia where there is sexism and racism? I mean, what advice would you give them to help them navigate that so they don't get pushed out?
I think what I typically try to say is don't let anybody tell you that you're not good enough to do something, because only you get to decide whether you want to do something, and nobody else should dictate that for you, and nobody can dictate that for you. I wish someone had told me that when I was, a young girl.
I honestly had no idea that it was that poor of an environment in academia.
I think people don't talk about it, or at least non-academics don't talk about it. Academics talk about it a lot. But yeah, I think, one of the things that I say that people forget is academia doesn't have an HR department. There's no person I can go to that, would help me resolve a conflict, for example. And basically there's people who have tenure are untouchable, right? You can't basically reprimand them in any meaningful way. So it's a system that's founded on these power hierarchies and exploiting basically the voices and the labor of young people in the field.
It kind of brings up something you were talking about earlier where, until you were going through grad school, you didn't really know what happened in the field. I'm curious, what are some of those misconceptions that you see outsiders or people just breaking the industry have compared to the actual realities of that profession?
I don't think anybody knows how much programming is in astronomy. People and I thought you just look through a telescope, and I don't know, I somehow thought the image that you saw would get in a paper somehow. I didn't really think too hard about how that happened. But that is completely false. Many astronomers have never looked through a telescope before, which
Really?
is shocking.
Wait,
yeah.
Louis, back that up. How does that work?
I honestly don't know. There are people who got into astronomy because they like instrumentation and, I don't know, don't love looking at the stars, for example. Or there are people who are theoretical physicists who just really like the problems that, the universe has in astronomy. So there's a lot of different types of people, and some of them, when you go observing, you're not looking through a telescope. You're hooking your computer up to the telescope to the data collector at the end of the telescope. And then you're sitting in a control room looking at your computer. So we don't get to see, really pretty images unless, that's explicitly what we're doing. But yeah, I think that's a huge misconception, is like, you get to look at the sky and be happy all the time, basically. And that's like, sadly not the case.
Learning how to code, you mentioned Python being one of the major languages you work with. Like, was that something you had to learn on your own? Are there courses? Was there training formally as part of your program? Like, how do you get that computer science or programming knowledge?
I wish there was training as part of my program. It was all like, figure it out, basically. So I like to tell people I am like a professional Googler. Like, I can't do a lot of things, but I can Google really well. And that, I basically have taught myself very, very mediocre Python, but I use it, to analyze data, and, that's all you need. So astronomers as a whole are pretty terrible coders, but it's because we're not formally trained. Like, we never take classes in it. So,
Wow.
Yeah.
And you mentioned that you worked on observation and also theory where you were simulating. What are the other areas that someone could be a part of in the field?
So the other major area in terms of research is instrumentation. There's a ton of work done on instrumentation that I don't know anything about engineering. There's no way I could do instrumentation. And then, I can totally talk about alternative paths, like being a telescope operator. There are people who basically live on the mountain full time and, either operate telescopes or do sort of technical stuff on the telescopes, engineering and otherwise.
And did you get your choice of what you want to go into based off of your preference?
Like, for observation and theory, it really is, you come to grad school and you choose a program in large part based on the research that particular department is doing. And so Berkeley is pretty evenly split between observational and theory, which for me was great because I didn't know what I wanted to do. But some people know they want to do theory, and so they go to, other programs, or observation on the other hand.
How do you fuck up as an astronomer? Like, I'm imagining breaking the telescope or something, or like, I'm just curious, like, what are the pitfalls you've seen people like?
Yeah. I have heard stories of people crashing telescopes, and these telescopes are massive. Like, let's see, the most recent one I used was like 96 inches or something. And that's the diameter of the mirror. And then think about like how it's like the size of a house, basically. And what happens is the telescope lives in a dome, and you have to turn the dome and open the dome for the telescope to see out. But sometimes people crash the telescope into the dome. I can't even think about it because I freak out. Also, like, falling asleep on the job is very bad. Like, if you're observing and you fall asleep, not good. Potential telescope crash coming. The other thing on the computation side is, I saw this story on Twitter. I don't know if they were astronomer or some other scientists, but they wrote a code to basically like get information from sub database website on a website, and he fucked up his code to where it pinged the website like 100 times a second or something crazy, and he triggered a DoD like investigation because they thought it was a cyber attack.
Oops.
What is one mystery of the universe that you want to know the answer to, or that you're just like super entranced about?
Just one. Okay. Just got really excited. So I said that I study the rate of the expansion of the universe. Well, the thing that hooked me about astronomy in terms of doing research on it, the number one fact is that we only know 5% of all matter in the universe. And everything else, 95% of the universe, is in the invisible form of dark matter, dark energy. And we just have literally no idea what they are. And so that, to me, as someone who's curious and likes exploring, 95% of all things in the universe is unknown, is like the most exciting thing to me.
Yeah.
That's a crazy amount, because like I always hear those stats, something like 70% of the ocean or something we've never explored. Yeah. And like that just, it kind of freaks me out, to be honest, just like how much is out there.
Yeah. The first time, honestly, it's funny you asked me if I was scared, or like if I get scared thinking about it, because the first time somebody asked me that, I was in college and I had never once been like, oh, that could be scary. Like it hadn't even occurred to me. And so they asked me and I was like, what? Yeah, I don't think I heard you right. What do you mean? And I guess like the unknown is scary to people. But to me, it's like, it puts everything in perspective. And so that to me is incredibly calming.
Yeah. We do have one question we've asked everyone who's been on the show, which is just kind of working with the topic of the show, being curious about professions that we don't know much about. Are there jobs or professions out there that you're curious about learning more?
Yes. Oh, absolutely. Neurosurgery, fascinating to me. I don't know how people do it. Anything to do with psychology is also fascinating to me. I feel like psychologists are heroes, and I don't know how they are so smart. Yeah, those are the two that pop to mind.
Sarafina, thank you so much for joining us on What the Fuck Do You Do? It was an absolute pleasure getting to learn more about astronomy and astrophysics, and we appreciate you joining us today.
Thank you so much for having me. It was wonderful.
Thanks again for joining us on What the Fuck Do You Do with Travis Fox and Shrey Panda. If you enjoyed listening, please make sure to subscribe to us so you don't miss out on future episodes. And if you're interested in a job that you're curious about being featured on the show, check the link in the description and let us know. If you liked this episode, we hope you subscribe to us on YouTube and Spotify and share the show with your friends. We really appreciate your support.